Welcome to session 7. Now, session 7 is an extension of the previous one, which is subroutines or subprograms. Now, session 7 is recursion. Now, recursion means it is a type of repeating the same part of code, but done differently to what we looked at in loops. In session 3, we looked at loops or iterations. They have a way of doing it. So they have either condition control or count control loops. They will actually repeat. But whereas recursions are done by a divide and conquer approach. What that means is, if you have a subprogram which is doing something, what if at the end of the subprogram, you're calling it again? So let me rephrase it again. You write a program, a subprogram, which does some task, but end of it, you call it again. By doing that, you can also repeat. Now, this is the most powerful way of repeating programs, and it's very powerful, in fact, but it's dangerous as well. The reason why this is dangerous is that it could actually collapse or it'll crash your computer, especially the memory usage is very high for recursive algorithms. Okay, now don't get scared. It's not going to damage anything. It's just going to restart your machine because it has to clear the memory. Now, why it has to clear the memory? Because when you call a subprogram again and again, every time it calls, it'll create all of the data structures and variables defined within the subprogram, a new copy or new allocation in the memory. So every time it calls itself, it is going to create memory stack. So at some point, you'll run out of memory, and that's where it is going to restart, because the best way for the computer to clear the memory is to restart. As you know, memory, the main memory, is volatile. So that means the moment you switch off, it just clears, right? So recursion is really powerful. And it's an advanced kind of construct of computer programming. But all you need to know at this point is recursion is achieved by, or repetition is achieved by in recursion by calling itself. So at the end, the last line of the code of a subprogram, what it does is it calls itself. Okay. In fact, the cost of this for memory complexity and time complexity might actually differ. That's another topic that we will discuss later.